do that, do the recording. I always forget about that. Okay. So what did we talk about yesterday? Yesterday, we talked a little bit about Auth in front-end web applications. Talked about how you might go about implementing your own Auth workflow. Talked about authorization and authentication and the differences. And then after sort of talking a little bit about maybe why building your own Auth system might not be the best idea, we then went from that to talking about Clerk, which is a pre-built Auth system you can integrate into an application you've made. And then we integrated Clerk into the blog app that Max had been working on with you for the past bit of time here. And we ended the day by adding some protected routes that you could go to and visit only if you were logged in. So today, what we're going to talk about is we're going to add on top of that material. So yesterday, the primary focus was on the front end. Today's primary focus is going to be on the back end. So today, what we're going to do is we're going to set up some code so that we can only make requests to certain routes on our server if we've actually logged in. So that kind of goal maybe dictates kind of a question, which is, how do you illustrate to the server who you are when you make a request? So if you think back to maybe some of the networking stuff that we covered with me, like probably over a month ago at this point, one way we talked about doing this is with a token. So going way back to all the networking stuff, I actually linked to the slide from that presentation if you want to go see. Actually, realizing I should probably paste this back in the chat again, just so I think everyone probably has it from yesterday, but in case you don't, let me just make sure everyone's got access. But going way back to all the networking stuff, a token is a unique identifier that's pre-generated by the folks who run the server, or in this case, it's going to be Clerk, but by someone who has control over the auth system of the application. And the idea is when you make a request to a server, you include this token, and this token is linked one-to-one with your user. So in other words, if you include this token, kind of the theory goes that the only person who should have access to that token is the user that's being authenticated with that token. It's a secret, so it shouldn't be something that anyone just out there has. If you have that token, therefore, you can act on behalf of that user and do whatever you want. So thinking back to the networking stuff, like what we did is we included a token in a header when we made some requests to prove to the server we were who we said we were. And that's exactly what we're going to do here. Only now we're actually going to be talking a little bit more in depth about how those tokens get generated and kind of where they come from and exactly how they work in the context of like a Clerk ecosystem. Before we move forward, any questions on tokens? Okay, sounds good. Yeah, I kind of already said some of this stuff. I guess I'll quickly run through it again. So it's a unique identifier pre-generated by the people who manage the server. It's secret. Don't share your token with other people. It's typically specified in the request, and some things used for authentication, which are what we're going to be using for it for today. Rate limiting, permissions are another word for like authorization. Okay, so I said yesterday, today was going to be a relatively easy day, kind of like yesterday. So we're kind of going to get right into it here and write some code. So in order to integrate tokens into our server so we can make requests with them and check to see if they're valid or not, we're first going to need a server. And we have our server already, the blog backend repository. So if you've closed it down from yesterday, I want you to get that back up and running again. So I've got my backend project here. I'm just going to run npm start in it just so we have it running. Oh, I do, though, have to stop another server I have running on that port. Forgot about that. Should be good now. Excellent. Okay. So I've got my backend started. That's all great. And hopefully things should work here. So if I go to localhost 3001 API online, that's what you should get, what the server gives you. And I'm guessing Max probably mentioned this, but just to explain like where that's coming from, in index.js, we've got the server get slash. So when I make a request to a URL in a web browser, it's by default going to make a get request. And this is returning back the JSON API online. So that's where that's coming from. Okay, so now that we got our server running, let's add a new endpoint that uses a token to verify the requester's identity. So in order to do this, we're going to have to do some more Clerk stuff. So Clerk is who's actually going to be generating and managing all our tokens, which is kind of nice. So it turns out that Clerk will handle all this for us, and we don't have to like do any sort of like custom logic, which is really nice, kind of coming back to what we talked a little bit about yesterday, where we're outsourcing all of our account system concerns to Clerk and letting them sort of handle all that. We don't need to build anything custom. So we're going to need to do a bit of setup, though. So what I'd like you all to do is if you've logged out of Clerk, go back into Clerk. So if you go to dashboard.clerk.com, should bring you back to where we were yesterday. And once you've gone to dashboard.clerk.com and you've logged in, if you've logged out of something like that, we're going to want to download a special thing called a JWT public key. So we're going to talk a little bit about what this does in a second. We're going to get it downloaded to start with. So if you go to the sidebar here, you've got in your app, your test app that we made yesterday. You go down on the left and you go to API keys. And it says show JWT public key. If you click on this, you'll see something that looks kind of like this. You want to copy that to your clipboard. So just that again one more time. So over here on the left, API keys. And then show JWT public key right here. And then click copy to your clipboard. Now, I do want to quickly point out that this is a public key. It's not secret. So you could share it. I mean, probably don't have a reason to, but like this isn't super critical that it stays secret. We'll talk about why that is in a second. Okay, so now that I've actually, I guess I should stop for a second. Has everyone been able to get the JWT public key into their clipboard? Cool. Sweet. So copy your clipboard. Now what we're going to want to do is in your backend code base. So if you open up Visual Studio Code with your backend here, in the root of your backend repository, I want you to make a new file. And I want you to call that file clerkpublickey.pem. So clerkpublickey.pem. So this PEM extension, tends to be the extension you use whenever you have a file that contains some sort of key, whether it be a private or a public key. So I'm going to paste in the thing I copied from my clipboard inside of this file. I'll say if you're managing this repository with Git, you can feel free to commit this if you want. It's not secret. In practice, if you were this was like a larger scale application, probably you wouldn't commit it. You'd sort of like have a bunch of different values sort of for like different environments or something like that. But yeah, it's not a secret value. You can commit it if you want. Okay. Actually, before we do that, has everyone been able to get that public key into that file on their system in the blog backend directory? Okay. I'm not hearing anything, and I'm seeing only a few thumbs up, so I'm just going to assume everyone's good. If you have any questions, though, feel free to interrupt me and ask. Okay. So we've now gotten this key added. So I think probably the way we're going to do this is we're going to set this all up, and then once it's set up, I'm going to walk through exactly what's going on, just so we can have all kind of the pieces in front of us and we can take a look at it. So now that we've got this key, we need to actually set up the code in our backend server to do the token validation. In order to do this, we're going to use this package, this NPM package called JSON Web Token, all one word, all lowercase. So I'm going to take this, I'm going to copy it. And then in my backend repository, I'm going to paste it. And what this will let us do is we can now import the JSON Web Token package into our JavaScript and use it. Okay. So now we get to the fun part, the code. Luckily, this is just going to be kind of largely one block to copy and paste. So we've got these imports at the top. So I'm going to stick those in our index.js file in the backend repository. I'm going to put those imports at the top. And then I'm going to yeah. So it doesn't really matter where you put this big block. All you need to do is you just need to make sure you put it above the server.listen and after server is created. So actually, make this even more straightforward for folks. Just going to put it right at the top. So all you need to do is you need to bring that in from the slide and then this in. Any questions about that? I realize we're going through this kind of high level, but I think this is, yes, this is the last bit. So we've got sort of all the pieces implemented. We've got our token file. We've got that package we brought in from NPM. And then we've got these two little bits of code we're adding into our backend. And then once we have this, we'll be able to make requests and see how it goes. Cool. I'm going to keep moving forward unless anyone tells me they want one more second. So what do we do here? Well, we've got this new /secret word endpoint that we can make a get to. So what I'm going to do is after I save that, I'm going to go over to my terminal. I'm going to run npm start again, kick that off. And then once I do that, I'm going to open up Postman. So what I'm going to do is I'm going to use Postman to make a request to this secret word endpoint, this get/secret word. And we're going to see what happens. So get to localhost 3001/secret word. Let me make this a little bigger. Okay. So what happened here? Well, I made a request to this endpoint, and I got back a few things. I got back a 401 unauthorized. And then I got back this body, error, authorization header not specified. So if you remember back to when we talked about all the networking stuff, 401 starts with a 4, so it means something's wrong with your request. 401 unauthorized in particular, and you can hover over it and Postman, and it'll tell you a bit more. But what that means is you didn't specify the proper authorization information to access the endpoint. Okay. Any questions? I guess I should say, has everyone gotten the code copied in, been able to get the app running? Cool. Hopefully you've all been able to make that request too and seen that same response back. Austin, go for it.
It's just in my VS Code, in the terminal. It's saying my node the app crashed, but it's working in the browser.
Hmm. Do you want to share your screen? Let's take a look. I'm not
Yeah.
sure off the top of my head what's going on there. Oh yeah. So when you see that EADDR in use, what that means is you're trying to start something on a port where something else is already listening to it. So I'm going to guess most likely you have this app running somewhere else in your system on the
Oh,
same port.
oh, it might be one of these.
Yeah. So
Okay.
I
Yeah.
would say go through there, make sure you've only got it running once. The other thing you need to be cautious about is that you're running like it in the right place. It's sort of pulling in all your latest changes. So I'd say if you can, quit it everywhere and just start it again
Mhm.
fresh once, just to make sure everything's good. Sweet. Looks like you're good. Excellent. Anybody else have any questions?
What's the expected output?
Expected output should look something like this. So making a request to that endpoint, we're not including any sort of authorization information. We're just making the request on its own. It should fail. It should, but importantly, the request should it should give you back a response. Your server should be there. Your server should start and all that. Cool. Okay. Let's talk a little bit about what this code's doing and sort of trace through what's going on. So when we make a request to get/secret word, we're starting to run this code here in this callback function here. The first thing we're going to do is we're going to get a value out of the authorization header and store it in this variable called header. And what I've done here, I've used a pattern that you see a lot in like more involved larger applications, but I think it's a good one to expose you all to, which is you'll see me here having a lot of ifs that are sort of short that all return inside of them. So this sort of pattern is called like the guard pattern. And the idea here is you're checking to see if a condition is true. And if it's true, then you sort of like handle the error and return. So what you do a lot of is like what you run this sort of if, and then below here, now you know that header is set. It's like it has a value in it because you check to see if it didn't have a value in it. And if it didn't have a value in it, you threw an error. So what I'm doing here is I've gotten this header, and then I'm checking to see are there a value in the header? And authorization header is not specified. That is the error we got back in Postman. So that's sort of where it bailed out the first time it went through there. Let's say the authorization header is specified, though. So I'm going to go over to here into Postman and go authorization. I'm just going to set this equal to like bogus. There we go. And then go send. So you'll see it's got the error gave me back this time is a little different. So what happened here? So header parts is header.split on space. So header is a string. That's the value of the authorization header. So what I'm trying to do here is split it based on a space and get the parts of the header. If there are not two parts, so less than two, more than two, if there's not exactly two parts, it's going to throw an error, send an error back. And that's what it gave me right here. So let's sort of try to get a little further. Let's give it a second word to sort of try to parse. Okay, so keeping on going. Header parts is zero, so that's the first word in that split up header parts. That should be bearer. So I'm checking to see if that's set. And in this case, why do I keep clicking over there? In this case, it's not set, so expected bearer. So another thing too, that's kind of a nice API design pattern that maybe it would be good to expose you all to. When I'm sending back a 400, I'm sending back in the body an error message that sort of reads in a certain way. That's very direct. It says exactly what's wrong. And in particular, if it's checking to see if something is a value, then it's telling you what it expected the value to be and what it actually found there. And I'll tell you that as someone consuming an API, when I get an error message like that, it's really nice because I'm like, oh, that's what it expected. That's what I put there. So I'll just change what I put there to be the expected value or something like that. So this is really nice because I can go over here and be like, okay, so I guess this needs to be bearer. Click send and get a little bit further. So also calling out here, I have all these different error cases. I don't just have one generic authorization failed error. This is also really nice because it means that it allows you as the user of the API to be able to troubleshoot what's going on. So we can kind of work through this a little bit interactively by just kind of going from error to error to error and kind of figure it out. Okay, so it expects the first word to be bearer. So we did that. Now, the second part is it's missing a token. So, or wait, is it? Invalid token, yeah. So I got a little further. So there are still two words. So that there's the bearer and the token. So that's good. Okay. So now we've gotten through all the validation checks. We're actually at the final, the kind of important part of this endpoint. So we've gotten through all the verifications. However, now we've got to actually verify that our token is valid. So at this point, the variable token here is header parts 1. Oops. Just happened there. Which is, in this case, bogus 2. So it's trying to validate bogus 2 being a valid token, and it's not a valid token. So it's failing. It's giving back this error, invalid token. In order to get there, though, we had to run this code. So this first line here, what this is doing is it's reading this file from disk. Read file sync is probably not the best way to do this if any Node aficionados are watching the stream later on. It's probably not how I do it in a production application, but for this kind of use case, it's fine. What this is doing is synchronously reading the data from the file and storing it into public key. So in this variable now, the string, you now have the contents of this file. So in other words, that public key we got from Clerk's website. Now what we're going to do, once we have that public key, we're going to put it into this jwt.verify function. So this jwt.verify function is from that JSON Web Token library. This is what we import or what we install with npm, and we're going to use that to verify our token. Now, I'm going to do a quick little digression here on what well, actually, let me finish this up. But after I say a few more words, I'm going to do a quick deep dive into like what exactly this is doing, because I think it's important you all understand it. But if this works, it gives you back this decoded value. If it doesn't work, it throws an error. So I've got the try catch around here to sort of handle the error. And if it fails, then it logs out what's happening, and that's where the invalid token comes from. And then if everything goes right, then down here, like the token successfully validated because in this catch I'm returning. So if you hit this branch, you return out. So it's sort of just the same kind of idea as this guard pattern. You're sort of in the main flow. You're always handling the success case. And then I'm handling the secret word at the very end. I guess one more thing I will mention on this whole guard pattern thing. Keep in mind that this is a very flat way of writing code. You're not really going much to the right, which is pretty nice. Like the highest indentation level I have in here is 3 indentation, or I guess 2 indentation levels, which is pretty neat. So anyway, I'd suggest looking it up if it's not a pattern you've been exposed to. It's made a lot of code I've written much cleaner. But let's talk a little bit about the JWT.verify thing. I guess before I do that, any questions on anything I just talked about what this route here is doing behind the scenes, other than the JWT verify function, which we're going to talk about in a second. Okay, sounds good. So, Terry, go for it.
Are we supposed to be getting the error from Postman?
Yep, you should be getting an error. So if you're making the request we originally made that at the beginning, you should get something that looks kind of like this. Authorization header not specified and a 401 unauthorized.
Yeah, I got that.
Cool. If you want, you can sort of try to some of the different permutations that we just walk through now, but it's just testing all the validation cases. You're more than welcome to trust me that it works, because it generally does. Okay. So JWT is this term that stands for JSON Web Token. So token, we know what that word means. JSON, we know what that word means, and web, I guess we probably all know what that word means too. JSON Web Tokens are a clever way of handling tokens that have gained popularity in the past like 3 to 5 years. I'm going to talk a little bit about kind of how they work and why they're kind of interesting. I guess I do want to say that this is a relatively bleeding edge technology. In most established applications, you won't really see them used. But in sort of like newer startup-y kind of stuff, it tends to be a pattern folks are really enjoying lately. So let me show you what an example JSON Web Token looks like. And if you all want to look at this on your own end, you can do that. You go to jwt.io, jwt.io, and then you scroll down a little bit to this debugger section. You can sort of see an example of what this kind of token looks like. So a JWT is fundamentally a token. It is a value that is given to you as a user of an API that is secret, you shouldn't share with other people, and it's a credential. So it validates that you have access to some sort of resource. It can be used for both authorization and authentication. We're going to only be really caring about authentication for the most part today, but you could use it for both. So this website here, this jwt.io website, is something that folks who work with these really enjoy, me included, because it has this little debugger tool in here. So what makes JWT kind of unique among tokens is the actual contents, the actual literal text of the token isn't just random letters and numbers. It actually means something. So our token here has 3 parts: the red part, the purple part, and the blue part. The red part is called the header, the purple part is called the payload, and the blue part is called the signature. And the way a JWT is always structured, it always has these 3 parts, and they're always dot separated. So you have the first part, dot, the second part, dot, the third part. You always have 2 dots in every JWT. Each of these parts is base 64 encoded. We talked about that very briefly way back in the networking section of Careers in Code. It's not that important. Effectively, though, like this data here, this JSON data, is being encoded and is ending up here. So if I, for example, were to go and change this from JWT to like JWT A, you'll see that the red text here will change. but the purple and blue will not. So everything in this red is going here. Everything in the purple is going here. And everything in the blue is going here. The header of a JWT, what this signifies is sort of includes like information about how the JWT has been like created. The payload is what you probably are most often interested in. This contains information about the user being authenticated. So their name, there's a bunch of standardized like keys in here, like IAT stands for issued at, so the time which the token was issued. Sub is like the subject, so who the token is referring to. Usually this is like a user identifier of some sort. And then the last part of a JWT is what makes it special. It's the signature. So the idea with the JWT is it relies on cryptography. So it relies on all the same sort of stuff that like makes your web browser secure with like the little green padlock up here. I guess it's not green anymore. It's just the regular padlock, but it used to be green. So the way JWTs work is a bunch of different ways you can secure them. But the way that is most used these days is with public-private key cryptography. I think we also briefly touched on this back in networking, but I'm going to kind of go through it again here, just because I want to make sure everyone understands this, because it's really important to realize why these are secure. So the idea with public-private key cryptography, or it's also called asymmetric cryptography, is what you have two things. You have a public key and a private key. No, I don't care about some random Java thing. So these are both behind the scenes generated by they're like really large numbers. And how exactly they're picked is not that big of a deal, but they're kind of like special. And when you generate a public key, you generate a private key alongside it. So you generate like a pair of them. And what happens is the way that asymmetric cryptography works is the public key and the private key are used for different parts of the operation. So the private key is used for encrypting. So if, let's say I have, I'm going to say a secret, a value called secret. And what I'm going to do is I'm going to encrypt it with secret with the private key. And then coming out of it, I might get something that looks kind of like this. So going to be like complete gibberish, not going to make any sense. However, if I take this value and I feed it into the decrypt function that take the gibberish with my public key, I get the secret back out. So why is this important? Well, it means that the person who does the encrypting and the person who does the decrypting, they require separate values. They're not a shared value. So if you want to hold something close and generate encrypted values, you can generate those, and then you can give those encrypted values to somebody with a public key, and they can validate that they're correct. Or they can validate, they can do the decryption. So the asymmetric, oh my gosh, asymmetric cryptography. I don't think I spelled that right, but I think you all know what I mean. Fundamentally, does what's going on here, does this make sense to folks? Any questions about like kind of what each key is doing and where it fits into the process? Yeah, Terry, go for it.
Can this work with let's say like you have like an encrypt, like you want to encrypt like your JSON, because in my capstone I use is like JSON. So will this also work with like JSON? You could like encrypt it and like decrypt it with this method?
this secret value here can be anything you want. So you could have it be like this, for example. And keep in mind, the secret here between these values would be different. So it would actually be like something like this. So it would be like a different secret value. But yes, totally. You can put any text you want in here, and it will encrypt and decrypt with the public and private key like that. And it's really funny you brought that up because we're kind of going to talk about that in a second. But before we do that, anybody else have any other questions? Okay, sweet. So the reason why we're talking about this is because JWTs, the way that they work, they fundamentally okay, I guess before I say this, taking a step back, normally if you have a token and you want to validate that your token is valid, I think we talked about this yesterday, but often you'll have like a tokens table. So you have like a database table of tokens. And what you'll do is when you want to issue a token, you'll add a row to that database table with your token value in there. And then if you want to see if your token's valid, you just check to see if the token's in the table. And sometimes you'll have like an expiry time. So you'll check to make sure that expiry time isn't after now or something like that. And what you'll do is you'll verify, okay, the token's in there. So if the token's in there, the token's good, and you let the user through. The things that makes JWTs special is with a system like that, where you have like a tokens table, you have something you're querying. You're like making a request to something, and you're saying, and that request might be the database behind the scenes, like a SQL query. It also could be like another API service. And what you effectively have to do is every time you want to validate that a token is valid, you have to ask that other thing, is this token valid? Is this token valid? And at small scales, totally fine. Not a big deal. This can become a really big issue, though, at larger scales when running like larger applications in production, which is why folks have started to explore like, how can we eliminate needing to do this while also keeping things secure? Because obviously, like, if you don't do that token check, like, if you don't have access to that data, like, how do you verify the token is valid? Like, the token's just random letters and numbers. So like, there's nothing in here to like let you do that. So what folks have come up with JWTs is a very clever way of solving that problem of how do you avoid making direct queries on like a database table. And they've solved it by using cryptography. So the way that a signature on a JWT works, I'm going to do something with this. Go header, payload, and then we're going to fill out our signature in a second. I'm also going to stick this down here. So in order to generate the signature, the way you do it with a JWT, with one approach, there's a few different ways you can do it, but the way that Clerk does it, is it takes your header and your payload, and it puts a dot in between them. So header, payload, and then what it does is this is on Clerk's end. What it will do is it'll encrypt it will encrypt this and give you some random letters and numbers. Actually, I'll do this. This is your signature. So what you do is after Clerk generates this, it sticks this on the end of the token, the JWT, and then this whole value is what it gives back to you. Now, on the client's end, and to be clear, when I say client in this case, I could mean like the front end, but it's also kind of the back end too in this situation, because the back end sort of is like verifying tokens. So I guess maybe the better thing to say is anyone other than Clerk would do the second part. So on anyone else's end, can I change this away from Java? I just want plain text. So then on anyone else's end, what they would do is they would get the token, they'd pull off the signature, and then they decrypt it with the public key. And if everything goes well, they should get header payload. So the idea here is, because of this nice cryptographic like separation of keys idea, Clerk can generate tokens using the private key, and anyone who has the public key, the thing we downloaded from Clerk's website, can validate tokens. So anyone who has a JWT, any JWT can validate it if they know the public key of the issuer. So you just have to pull off the signature, decrypt it with the public key, and see if it matches header.payload. And if it does, great. If it doesn't, it's invalid. Simple as that. So it's a pretty clever way to solve this whole problem. Is it over-engineering for the kinds of scales that your apps are going to build, probably going to operate at in the near term? 100% it is. But this is sort of what Clerk uses, so we kind of just have to use the things that they provide. Any questions on this whole thing here, this whole workflow of like how Clerk's generating the JWTs and then how we're validating the JWTs? Okay, cool. I will take this and I will put this in Slack for everyone's benefit, just so we have it kicking around. Okay, cool. So fundamentally, what this function is doing here, this JWT.verify, it is doing it is doing this. So it is pulling that signature off, decrypting it, making sure it matches. And if it matches, what it will do is what it decodes out of the JWT is the payload data. So it'll sort of decode that and give it back to you, because that's usually what you care about. And then if it doesn't verify properly, then it will throw an error, and that's that. So just as an example of showing you kind of how the validation error would happen, if I went like header, payload, signature, something that just like kind of by eye could be a JWT. Or it'll say invalid token. Oh yeah, because that's right. That's what it should give me. Yeah, so you see here, it's had a few different errors given us, but JWT malform was the first one, invalid token. So yeah. Okay. So now we've got our endpoint on the server that can handle processing our JWT tokens. We need to actually generate them on the client side. So let's talk about how we might go about doing that. Yep, we already made that request. Yeah. Okay. So here's what we're going to do on the client side. What this does, this is a bit of, I would say, like moderately complex React code here. There's a couple hooks involved that are kind of doing some things. I'm going to copy this over just verbatim into my editor, and then I'm going to walk through it. So this is in the front end. So I got to go back over, not from the back end. I'm now on the front end into app. I'm going to close all of this stuff. And then we're going to add this into our protected sign-in component. This is what we made yesterday with the sort of like the red text and the welcome first name and the user button. So that's where we're going to put all our stuff. But I guess before I do that, I need to stick a couple imports to the top. So I'm going to do that, and then also add use auth here. So we're going to use a new hook today. We used use user yesterday. We're going to use auth from Clerk. And then I'm going to take this. I'm going to copy this into protected sign-in. And then I'm going to add the secret word here above our user button. Okay. So if I save this and I go back over to my app and I go to protected. Oh, and my app were to be running. That's kind of important. What you're going to see, secret word gorillas. This here is coming from over in our backend, right here. So that's the response from that endpoint. And just to prove it to you, I'll change it. And I'll reload my page, and it's changed. So it's definitely coming from there. Okay. Before I walk through this, did anybody have any difficulty copying this code into their project? Okay, sweet. Let's talk about what's going on here. So we're using a few React hooks, built-in React hooks here to make this component work or add this functionality. Use state and use effect. I'm pretty sure you're all are familiar with those hooks, so I'm not going to go into exactly what they're doing. But if you have any questions in particular, let me know and I can talk about it. So I'm adding a bit of state to this component, word, and I'm adding set word to sort of set that state. And it's just going to start as an empty string. And then I've also used this use auth hook. We're going to talk about that in a second, but I've sort of put that there. That's a new addition. Okay. This use effect here is kind of where the majority of things are going on. Oops. So what I want to call out here is the first thing I'm doing in this use effect is I'm calling this get token function. The way Clerk works, it makes you request a new token every time you want to make a request. This definitely has its pros and cons, but it's just sort of how Clerk works. You just kind of have to like buy into it if you want to use Clerk. Get token is what you get from this use auth hook. You destructure it just like we did with user yesterday. Get token is a function that returns a promise that resolves to a string token, just like fetch in that way. So returns a promise. You have to sort of like, it puts a value, it gives you back an empty box. It puts the value in the box later. Hopefully at this point, you all should be relatively familiar with promises, have enough practice of using them a few times. So get token here, this is asynchronous. Once that promise resolves, it's going to call this callback with a token. This token value here, this is going to be a JSON web token. So this is the thing we need to include when we make our request. Then, this code should hopefully look relatively familiar to you all. We did this in the section I taught previously. So we're making a fetch request to our secret word endpoint on our backend. We're including in this request some headers. We're including authorization, bearer, or token. And then this thing returns a promise. And when that promise resolves, this callback gets called. And I've got a little check here just to see, like, did the response come back successfully? You may or may not have run across it yet, but response.ok is a neat little thing with fetch where if you have a status code that's a 200, response.ok will be true. Otherwise, it'll be false. So it's a nice little way to quickly be like, is a response coming back successfully? And you don't have to like manually check status codes and stuff like that. So that's cool. And then it'll similarly above have this sort of bailout pattern. So I'm bailing out early if response is not okay. And then I'm getting the JSON data from the response body, and then setting the word state to be JSON.data. So remember back here, this is our JSON response, our body, and then data is gorillas. So to show you here what's going on in the actual application, if I go over here to network, I clear my web history here on the network thing, I go to secret word, you'll see that in this request being made, making it to secret word, in the authorization header here, I'm including bearer in this really long token. One of the annoying things with JWTs is they are very long often, and that is kind of a pain to deal with them for that reason. But this is the token, or JWT, that was generated. To prove it to you, if I come over here and I paste it in the thing over here, the debugger, you can see this is actually what's included inside of the token. So Clerk includes some sort of like built-in metadata here. Linux is really particularly interesting, except for sub. We're going to talk about this in a second, but keep that one in mind. We're going to come back to this sub key. Now, if we, I haven't really done this. I don't know if I want to do it now, but in theory, you can actually give this tool your public key, and it can actually verify the JWT is valid for you too. In practice, I never really use it for that, but it should do that, which is pretty cool. This debugger is pretty neat. And if you end up working with JWTs a bunch, it's like a helpful tool to know that exists. Yeah. Okay, so fundamentally what we've done here is we now have an API endpoint we can make a request to from our web application with a token generated by Clerk. And this endpoint is we're only able to make a request to it if we are logged in, if Clerk's able to generate this token. If we don't, as you saw when we tested it before, if we make a request to that endpoint without a token, we get back a 400. So what we've effectively done here is we've created an endpoint that requires authorization, or authentication, excuse me. Requires us to be logged in before we can access it. So the use case for this kind of thing is all over the place. I imagine if you're thinking about your capstone, if you have any sort of auth requirement for it, you can probably think of some examples. But one example, let's say you only want to allow users who are logged in to be able to like view a certain web page. Well, here you go. That's kind of exactly what's going on here. Or maybe you only want to make it so that like if a user logs in, you only want to return like data that is related to that user. Maybe like you log into Gmail, you want to see all the users' email messages. And if someone tries to access that endpoint that gets you back all those email messages and they're not logged in, then you obviously want to like give them an error because they're not allowed to do that. So I'm conflating authorization and authentication a little bit there, and we're going to talk about the authorization thing in a second. But in general, like this sort of pattern of requiring an API token to access an endpoint because it's protected is something that's very common, that is every application of sufficient complexity includes it. Cool. Anybody have any questions about anything related to this endpoint, making a request from the front end, the server code, what Clerk's doing, anything we've talked about so far? Okay, cool. So, yep, secret word gorillas. Excellent. Yep, okay, I already showed that, but I'll show it one more time. Take note, you got a 200 okay, not a 401 or anything like that, so things work. Okay. So, when I said today was already, so what I think we're going to do, let's talk a little bit about authorization, and then let's take our break. And then when we get back, I think we're going to do a little bit of like a mini project that's going to require a bit of me figuring out things on the fly. So I guess for context, as you probably would imagine, most of us instructors, we've had some of these presentations from past cohorts and kind of just adapt them every time. And there's a section at the end here that I wanted to do, but I didn't get a chance to actually adapt. So I think we're going to try to go through that, and we'll try to figure it out on the fly and see how well I do. So that'll be fun. But before we do that and take our break, let's talk a little bit about authorization. So remember how I mentioned this sub value in the JWT? So it turns out this is actually the identifier in Clerk of the current user. So this value here, user2LGN, user2LGN. So what this means is you actually know which user logged in through this token. It sort of gives you that ID for free. Now, you might need to make a request to Clerk and get that information. Or if you do something fancy like Joe and I were talking about yesterday, where you have like webhooks that sync stuff to a database table, you can make a query to your database with that ID and get that row in that table. But fundamentally here, you now know someone who's allowed to log in or allowed to access the endpoint is making that request, like someone who's authenticated. And you also now have a token or an identifier you can use to perform authorization on them as well. So if you know their user ID, you know who they are, and you can use that to figure out, okay, if I knew who they are, do they have access to this particular endpoint? So just to give you an example of what that might look like, how you might actually go about accessing that. I'm going to stick in my code here, console.log decoded. And my backend code should have reloaded here. And then when I make a request, again, to this endpoint, you'll see it's going to give me back out this data being was in the JSON Web Token debugger for payload. And in here, you'll see sub is our user ID. So this is just like a JavaScript object. It's sort of decoding that, parsing that JSON for you automatically. So if I go over to my editor here and I go .sub, and I restart my server and I make that request one more time, you'll see now I'm getting the user ID here. So now I can do whatever I want with that. There is a Clerk API endpoint you can make a request to that'll give you back the user information for the user with that ID. Now, if I had been more prepared, I would have had that ready to go here, so we could show it all to you. But I think you're just gonna have to take my word for it. You can do it, because it's gonna take me a second to figure that out. Well, we'll see. I can do this in like a minute. We'll do it. But otherwise, you might have to take my word for it. Clerk docs get user info for ID. Server, maybe? Node API. Yeah, this is what I'm looking for. Oh, no, it's not what I'm looking for. Womp, womp, womp. This I think is what I'm looking for, maybe. Maybe? Maybe. Front end, back end. Let's just see what this is. If this it all seems Clerk client, yeah, I'm not excited by what I'm seeing here. There we go. This is what I'm looking for. Okay, I mean, we have the time. Let's go through this, see how things go. This could be a total disaster, total train wreck, but we'll see. Okay, so I'm going to install this Clerk backend package. Actually, let me also put this into the chat. Everyone who wants to can take a look. Okay. So I'm just going to go through this just top to bottom, this little tutorial, and see what I can make of this. So I've installed the backend package. So I'm going to, in my server, do something sort of like this. I'm going to import that. And I'm going to make this Clerk client thing. I'm gonna need a Clerk secret key. I'll get to that in a second, though. Yeah, okay, whatever. Is that okay? Yeah, it's more. There's more than this, right? I think get user. Yeah, yeah. Okay. So now we can do like Clerk client dot users dot get user decoded decoded stub. Okay. So what did I just do here? Well, so I installed the Clerk backend package. I added in the I added in the import for it into my backend code. I'm pulling in this. I'm using this create Clerk client thing with this backend package exports, and I'm going to create it with the secret key. We're going to get that in a second. And I constructed this Clerk client thing. And then just following their documentation, like they have an example here, Clerk client users get user. So I'm just going to try that. I'm going to put the ID we got from before into the user ID thing here. If this works, it should return a promise that gives me out a user. I should be able to log that user out here. So in order to do this, we're going to need a Clerk secret key. So going back over to API keys here, there's a bunch of different things we needed from this page. We needed the publishable key yesterday. We needed the JWT public key just now. Secret keys are kind of the last big thing. So a secret key is like backend only. It's like a token you can use to make requests to Clerk to do privileged things. So this should never be in a front end project. It should be used like you can have access to like manage anything in the Clerk dashboard with this token. So I'm going to copy this to my clipboard. And then I'm going to go over to my backend code. Actually, wait, no, I'm going to do this a different way. I'm going to go, what was this? Clerk secret key. And then npm start. I think you all are familiar with this, but this is how if you want to run a process with environment variables set, which is what these are, how you typically do that. So you could also put it in like a .env file and use a package to pull that into your JavaScript app. But this is just sort of easier, especially since we've only got one here. Okay. So if I did all this right, if I come over here and I refresh my page, see, it took a little longer for gorillas to show up. And if I come back over to my terminal, you'll see, yeah, I've got a lot of stuff printed out. So it looks like, yeah, all this user metadata. So first name, last name, email, tons of other stuff. If I take this image URL here and I pop this over to a web browser, you see there's my little avatar image thing. So yeah, and we could do whatever we wanted with this. Like, let's say you wanted to do something like so this is like an authorization example. So I could do something like only allow in users that have an email that ends in @gmail.com. So if I wanted to do this, I could do something like if user dot primary email address, I think that's what it is, the email address, yeah, So you can associate multiple email addresses with one Clerk user. So they have like a primary, so that's just what I'm going to use. So if the email address, an email address can also be null. So like in the case where you have signed in without an email address. So if the email address is set and email address dot ends with @gmail.com, then send a secret word. And if not, then send other word. No Gmail ending. Something like that. So what I'm doing here is I'm getting the user information, checking to see if the email address is set. And then if the email address ends with @gmail.com, and I'm just going to send gorillas. If it ends with something else, I'm going to end with no Gmail ending. Cool. So if I come back over here to my server, it's restarted. What I can do now is if I refresh the page, you'll see you have gorillas. If I now sign out, and I were to, for example, sign in with like my work email, which does not end in gmail.com, and then go to /protected, no Gmail ending. So you can see how the behavior is changing based on the user information. That's fundamentally like authorization. Any questions on any of that? To be clear, I wasn't expecting you all to follow along with me with what I just did there. I'll commit the code after this just so it's in the repository with all of other Max's stuff. But any questions on that? Okay, sweet. So I think we'll probably take our break now then. Let's come back at like 7:15, I guess. That's like half an hour. And then when we get back, we're going to kind of just ad hoc figure out these last few slides. And I guess I think I have a couple more left, but we'll get through these. We'll probably also end a bit early today, just like yesterday. And yeah, and then I think we'll be good. So, oh, I got to give you all an attendance word. Your attendance word for today, attendance word is authorization. And back at 7:15. Sweet. Well, see you folks then. So, where do we leave things off? Where we left things off, we had talked about how to set up Clerk with our backend to validate tokens. So we talked a little bit about how you might add an endpoint that includes token validation logic. We talked about mechanically what you would need to do to validate a token, to unpack that from the request and to parse it and validate it. We talked about JSON web tokens. We talked about validating JSON web tokens and using cryptography, in particular asymmetric cryptography. And in order to do that, we had to download a public key from Clerk that we could then use to validate that those tokens were signed and created by Clerk with the corresponding private key that they have. So what we're going to do now is two things. We're going to start by going through a bit of an exercise that I hadn't quite adapted, and we're going to see if we can make it work, which is going to be fun. And then the other thing we're going to do is we are going to, at the end, talk a little bit about maybe some ways we could adapt our code to be a bit more reusable and dry. Okay. So let me start by sharing my screen. So this was kind of the thing I didn't get a chance to adapt. And since we have the time, we're going to see if we can try to do it here. So if you remember our existing code, we're giving each user a secret word, a different secret word. Or sorry, a single secret word. We're sending them gorillas. I'm also actually going to comment all this out just because it's useful, but like for this example, we're not going to want to use this just so we can have just a single gorillas thing being returned. So the challenge here is I want to make it so whenever you make a request to this endpoint, as a user, you get back a different secret word. Now, there's also one other important thing, which is you get back a different secret word, but every user always gets back the same secret word. So in other words, I might get back gorillas, and someone else might get back bananas, but they'll always get those words back. If I get back gorillas, they also won't get back gorillas. So in particular, this is kind of another authorization example. This is an idea where you want to change what's being returned based off of the user data. So in order to do this, we are going to install a package that generates random words. This random word package, assuming this still works like it did a year ago, we'll see, generates random English words. I'm going to install that package. You're welcome to follow along with me if you'd like, but not a requirement. Okay, so this is where things are going to change because I'm doing this in a different project than I was doing it in last time. So we're going to figure out together how exactly I should go about changing our user model. So I guess let me explain kind of the thought here. So I want to add a table to our database. I'll call that database maybe like user random words or something. And that table, I want to have two columns, the user's ID and the user's random word. And the idea is when I first make a request to this endpoint, if they don't have a random word row, I'm going to make a new row for them and generate them a new random word. And then on future requests to the endpoint, I'm going to read from that table and see if I can find a row that has the user's ID. And if the user's ID is already in the table, then I'm going to return the corresponding random word. So in other words, the effect here is for the same user, you're always going to get back the same random word. And every user is going to have a different random word, just like I had defined. So what we're going to do for this is, I'm pretty sure, so Max had this user model. I think I'm going to want to make a brand new model. So I'm going to do something like copy this, paste this. I'll go like rename. I'm going to call this like random words, maybe. So random words model. Let's go like maybe random word. Yeah, Max is doing singular. So keep an ID. And then I want clerk ID. And I want random word, both strings. And here we're going to need to export random words model. Sweet. Over in here, I'm going to pull my random words model out from the file. Let's see what Max is doing here. So I guess we'll go just kind of copying what I'm seeing here kind of blindly. Random words model. Okay. Okay. I'll add that to the export. There's no sort of foreign keys involved here. This is just a totally separate and isolated table. No sort of relationships. Okay. I think that's all I need to do. Let's see if it does the automatic migration. So if I do npm start. Okay, it didn't give me an error. Okay, we'll go with that. And until it breaks, and then it's probably because the migration didn't run. So what should have happened there, hopefully, is it should have created a table. SQLi should have made a table called random words, or random word, I think, that had those two columns, that had, well, ID, clerk ID, and random word. Okay. So now, again, we're going to play the game of, let's just copy what Max did. Okay, I like the look of a create. We're going to need that. I like the look of find where. We're going to need that. So what I want to do is I want to random words, find one random word where the clerk ID is decoded dot sub. So that was that value in the JWT payload that had the user's ID in it. Something kind of like that. Okay. So then if we have our matching user here, and I want to do something like, I guess I'm assuming that matching user is going to be like a user or null or something. I guess I'm not sure exactly what find one's going to return. Let's see what the internet has to say. Sequelize return or find one. Yep. Okay. So it's going to give me back a null if it doesn't exist. So I'm going to do something like what does it want to do my indentations for here? That's 2. No, I want. Okay, whatever. So I'll do something like if matching, or not user, matching row. Matching row, then matching row dot, I think we want random word. Yep, random word. So if a word is found, return it. And I'm going to follow that same pattern I've been doing a bunch today and just bail out of this early. So effectively, now down here, matching row is null. Like we know that for sure. Because we check to see if it was set up here. So if it's not set, it's got to be null. Okay, so if the word was found, return it. But if the word wasn't found, then we're going to create a random word. Let's go back over to the presentation here. Also, I'm kind of just cruising through this. If you have any questions, please call them out, or if you want me to slow down and talk about anything, please interrupt me. So I'm going to steal some code from this. Okay, so random word, excellent. Random word. Okay. So I'm going to do something like import random word from random word. Sure, that works. And then okay, so I'm going to generate my random word. And then I'm going to create a random word. So in order to create this new row, I've got to set 2 columns, the clerk ID and the random word. My clerk ID needs to be this decoded.sub thing. So remember, that's what's coming from the payload of the JWT. And then my random word needs to be word. Okay. So once this has been created successfully, I should also make it clear I'm not handling errors very well here. In actual code, you'd want to do that, but I'm just trying to get the gist down here so you all kind of get the idea. But just want to make that explicit. You would actually want to like have catches and handle errors, or if you're doing this all with async await, like handle it properly there. But anyway, so we've generated our word, we've created our random word, and then once we've done that, then we can do something like this. Okay, so let's walk through this here. So all this is the same code. This is the new code here. So we're going to try to see if we can find a random word for this user. And then it's going to return the result. It's either going to be a row or null. If we've got a row, then return the random word. So in other words, if there's already a row that's been generated. If a row hasn't been generated, then generate a random word, create a new row with it, with the clerk ID and with the random word. And then once that create's done, then return the random word back to the client. So Joe asked, is there a functional difference between async await versus .then? Great question. So this is something that I think Max and I have had some friendly discussions, arguments, I don't know what the word is, about over the years. So to answer your question, there isn't really a fundamental difference. What actually happens behind the scenes in sort of older environments is actually the async await gets compiled down to .then and .catch. So it is kind of fundamentally the same. So the reason why you see me use .then all over the place is because, especially with you all, I want to make sure you all have a deep understanding of what's going on in all the asynchronous behavior. This is some relatively trivial stuff, but what can become a problem is if you get super familiar with using async await and don't actually understand what's going on behind the scenes, and you can write yourself some logic that can do some very weird things because you don't actually understand what's going on. So when I'm teaching, I tend to try to use .then and .catch and all the sort of like explicit promise methods like that, just to make it very clear what all the asynchronous behavior is, what's going on. In actual code, I would not be doing this. Like if you look at any code I write professionally, I've got async await everywhere. And I think in practice, like that's probably what you'll end up doing as well. But I am of a real strong opinion that you shouldn't start using that stuff until you can really deeply understand like .then, .catch. You can actually follow promise chains because you need to debug things. But I think also the thing that you'll probably discover with time is async and await actually has some very weird bugs and edge cases that are very subtle, in particular around using them in loops and stuff like that. And they actually aren't technically bugs. They're actually like expected behavior, but like it can be very confusing. And the first time I ran into a few of these things, it took me days of troubleshooting to understand what was going on. So I'm a big believer in like understanding all this fundamental .then and .catch stuff, and then like layering on the async and await once you're like really comfortable with it. And Max is a different approach, and that's fine. It's good to be exposed to many things, but maybe that gives you some kind of context on why I've been doing things the way I have been. Did I answer your question? Sweet. Okay. So I think this code should work. So I guess here's the moment of truth where we see if the database migration made if that new table got created. So I'm going to go back over here and I'm going to refresh. And we're going to see what happens. Oh. Did the app crash? What happened? Yep, it crashed. My random word is not defined. Ooh, that's fun. What line is this? Oh, yeah. Random words, not random word. Oops. Let's try this one more time. Okay, here we go. Yeah, I guess it did create the table. Excellent. That's a fun word, Herculeses. Is that really the plural of Hercules? I kind of don't know if I believe that. That's that's special. Okay. So if I refresh this, you'll see the word stays the same. So it's because you have that one row stored in the database table. I can sort of show you the thing in Beekeeper in a second if you want to see what that looks like. So this is with my work email. If I now sign in with my personal email, now I've got amending. And if you see I sign out, I sign back in with my work email, we should get our friend Herculeses back. Yep, there we go. So here's a great example of authorization. So imagine swapping out this random word for something like a list of a user's to-do list items or a list of a user's Gmail or email box entries. So you can maybe start to see here how this is an approach you can use to start to segment data by user. A very common thing you'll do in applications is have database queries that give you back a list of rows from a table that do like a where user ID is equal to some user ID. And that's kind of fundamentally what we're doing here, just like one column or zero column instead of a list of them. Okay. Let's get this open in Beekeeper so you can see kind of what this looks like. But any questions on any of this? Okay. So now comes the part where I struggle with another tool I don't use very often, and we see we get to watch. You get to laugh at me in your head if you want. Okay. New connection. I like the sound of that. Oh, yeah, there we go. So this is a Postgres database. And it is on localhost 5432. My user is demo. My password is demo. I'm pretty sure my database is demo as well. Heck. Oh, name.
You do already have a localhost 5432 on the other side if you need it.
I
looks
do,
like.
but this is something old that probably doesn't work.
Oh.
I'm kind of fancy, so Max probably instructed you all on how to run Postgres to run globally on your computer, and you probably have gotten so used to that. I don't really like having random daemons running in the background on my computer. And by the way, that is actually what they're called, daemons, only spelled DEAMON. It's like weird Unix lore stuff. I don't like having like these random processes running in the background. So I actually will start it up dynamically. I have it in what's called a Docker container, which is fancy. I might talk about it a little bit with Nathan in a few weeks with some of the infrastructure stuff. But I just sort of started up dynamically. So I've got it running off in a terminal somewhere else. And this is probably an old instance of it I ran like a year ago. The name is, oh yeah, perfect. Thank you. Okay, I'm just gonna call it careers in code. Save. Okay. And now if I want to connect to this, okay, perfect. Public. Yeah, there's a bunch of crap in here. There should be a random words or something like that. They've got a bunch of other crap in this database right now. So this isn't just for this demo. You know what? Oh, I know why, because I connected to the wrong database. Okay. log. That's what I want. Yeah, there we go. Perfect. Comments, posts, random words, users. Okay. So random words here. There we go. We see we have clerk ID, random word. Oh, nice. It also gives us the created at and updated at automatically. That's sweet. So let's say I was like, this Hercules offends my sensibilities, and I want to make this some other word, like sensibilities. And I probably spelled that wrong, but whatever. And I hit apply here. You'll see now we get that there. So kind of cool to see that plumbing going through the whole stack from database to backend all the way to front end through some network hops along the way. Cool. So that actually went way smoother than I thought it was going to go. That's great. Any questions on any of this? Cool. Okay, well, we have like 2 or 3 slides, and I think we're done. Oh, yeah. I guess last time my word was muleteers. This random word library generates some real crazy ones. Okay, so refactoring wise, something you may consider doing is moving out your token validation logic into a middleware. So what does that look like? I don't know if Max has talked about middlewares with you with Express. But here we have like server.use, so cores, express.json. These are what are called middlewares. This is a cool little thing you can do with Express, and actually with a lot of HTTP frameworks, where you can sort of give a request to some code that runs before your actual request handler runs. So what you can do is you can do things like parse auth headers, and you can like attach data to the request object that you can then use later on in your actual requests. So what we're going to do, I'm going to copy this because this is it's generally the same code. So I'm making this function here called validate user token middleware. It takes REQ, RES, and next. So should look pretty similar to REQ, RES here. Middlewares, though, take one more parameter, next. Next is a function. And the way that middlewares work, the express sort of way you do them, is you could request and response are exactly what you would think they would be. Next is a function you call at the end of your middleware to say, I'm done, move on to the next middleware. So it's fully asynchronous. Like after this call happens, it sort of express goes down the call stack, and like anything after this never runs. So just sort of like another one of those weird asynchronous things where they can't actually return because it's an asynchronous function. So you got to do a callback. That's sort of how they handle returning in this context. So this is the same logic as before. So checking all the headers, doing all the validation. This should look pretty familiar. Getting the public key from Clerk. The one new thing is instead of doing something with our key, we're going to store that key into req.auth. So interestingly here, like we can add things to req. This is a pretty common pattern you'll see in middlewares. And now in secret word, we can now, if we want to get access to our Clerk, our Clerk user ID, in other words, decoded.sub, we can do something like req.auth.clerk user ID. Oops, I mean that. And this will work in any request handler. The way that middleware works is they're global. They run for everything. There are ways to sort of scope them to sort of like subsets of requests. For now, though, we're just going to assume that all your routes in your whole application require access via a token. Like you need it to be logged in to view them. That's not crazy uncommon. It does happen. Sometimes you might need 1 or 2 that aren't, but the majority of endpoints in sort of like real APIs tend to require some sort of like gating by being user logged in. So what I'm going to do, I think I had this code Yeah, I'm going to take this, all this code here, and I'm going to delete it. And then instead of decoder.sub here, I'm going to use the value for middleware. Yeah, the indentation's all messed up here. Sweet. Okay. Yeah, there we go. Okay, so I've also need to get rid of that. So we've got this validate token user middleware. The way we use this and actually define it as a middleware is with server.use, just like these other built-in middlewares. Behind the scenes, this actually looks like this. Like it has a function that has req, res, and next. And it just does some things around JSON body parsing. This CORS one will inject proper CORS headers into all your requests. You don't have to deal with that in your clients. Things like that. Okay. So now that I've done this and I save this, if I go back over to, no, not that, over to my app in my web browser, you'll see it still works perfectly fine. So I've just sort of moved all that auth code off into a middleware. But what's cool is now all of our endpoints require auth. So if I try to make a request like /posts, it's going to require that I include a token, which probably will break some things. So maybe Max might have to sort some stuff out with you, or you might want to you might choose to comment this out for now, or just have it in the one request. But I think it'd probably be a good idea to have all these take tokens if that's kind of the goal, for someone to be logged in to view this stuff, or if not, that's fine too. But yeah, so like using a middleware like this is a pretty common pattern, something you'll see very often for handling auth level concerns. Any questions about what I did here with the middleware abstracting the logic out and how that kind of changed things? Okay, sweet. So, I want to talk through quickly what you might do if you wanted to build a CRUD app that had like all the CRUD endpoints and used auth to sort of validate that a user included a token when every request was made. So as an example, think about like a to-do list application. This is a pretty straightforward one. So what you want to do is in your web application, just like we did with the blog app, you want to force a user to go through Clerk's authentication workflow when they initially visit the app. So they would go to like /, they would go through the Clerk login workflow. You have sort of the setup we did with the protected endpoint. You just do that on /. And then once they log in, they see like the to-do list app. And then that to-do list app, when it loads, just like the New York Times project, you would make a request immediately to your backend and get back data. So you get back a list of all your to-do list items. On your backend, you would then want to have a bunch of REST resources for your to-dos. So maybe like get /to-dos to get a list of all your to-do list items. Here's sort of like roughly what the SQL might look for that. You can kind of convert it into SQLize if you want, but that's kind of what the query would tend to look like. You could do like post /to-dos. So that's like create a new to-do. And then delete to-dos ID. So you can sort of have like get, so like read, create, delete. You might also have like a put /to-do/ID if you want to allow users to update it to do, maybe like check one off. So you'd set up all those endpoints, and then you'd have a Clerk middleware that validates if the user's token was included before they hit all those endpoints to make sure that they're logged in. And in each of these endpoints, we're using the user ID. So that's sort of like how we're tying into that auth data. And we're using that user ID to filter our results or like change data we're including in database queries we're making. Finally, then, you'd also want your database to have something like two different tables, maybe like a Clerk user table and a to-do table. So the Clerk user one, I guess, is optional. It's something I tend to like to do. I sort of talked about this with Joe yesterday, but having a table in your database to manage all of your users tends to be good. You can even just do something if you want to do like the cheap and dirty way of like when you have in your auth middleware, you validate a new user, just create it at like the auth middleware layer. So just like make a new row in your database if that user hasn't logged in before. And that could work. And then you also, of course, need a to-do table. So you're making all these queries against some sort of to-do table. So you need a to-do table with the ID of the to-do item, the created user ID, so that's so you can filter by which users created all your to-dos, and then text, so the to-do list item contents, and maybe like a complete Boolean if you want to handle checking, and like you can kind of the world's your oyster from there. So this sort of set of, I guess, like things you need to make is a pretty typical set of like pretty typical set of infrastructure you'd want for a relatively simple CRUD application. Any questions on any of this? Cool. We talked about Clerk webhooks yesterday. I'm not going to go into it again, but if you want to have a user table, that's a great way to handle it. Okay, that's all I have for today. So I guess anybody have any other questions about anything we've talked about yesterday or today, or any sort of user related problems in their capstone they want to run by me or talk through? Okay, fair enough. Yeah, there's hopefully this is it's connecting some dots though and giving you some ideas on how you might be able to use some of this in your capstone or other projects. So cool. Well, as always, my Slack DMs are open if folks want to reach out. I'll also say that I think this is the last class I'm teaching for this cohort. So I think this is the last time you'll see me as an instructor in the instructor role. Near the end, last week or two is like capstone is sort of like capstone focus work. I'll probably be around in and out for that. Usually Max invites all the instructors to help out. Also, I'm up in Syracuse like every month or two. Usually, it's been a little longer than that. I need to go back up, but I wouldn't be surprised if within the next few months I'm at an open hack. I try to make my trips line up so I can stop by and say hi because I like to catch up with all the folks there. So if you become a regular there, you'll run into me eventually in person. But yeah, otherwise it's been great to teach you all. You've been such a great cohort, and like I mean just being like totally candid, like really with it. And it's been like it's been an interesting teaching journey for me with this time around because like things have gone faster and I've been like, oh no, I need to have more material. It's just a good problem, but it's just not what it often ends up being. So yeah. Anyway, great to teach you all, great to see you all again, and hopefully see you all again at the end of the program, or if not, at an open hack at some point. But yeah, have a good evening, everybody, and see you when I see you.
You too. See you soon. Thank you.
For sure. Bye.